In this lesson, we're going to conclude our subsampling lectures with talking about the analysis of averaging versus subsample. So let's get started. There are two scenarios that kind of pop up with this type of analysis. We can have balanced subsampling, so the number of subsamples per experimental unit is the same. In this case, it doesn't matter whether you want to do an analysis of the average or subsample. You can average the subsamples of the EUs and complete the typical CRD analysis or whatever other analysis you're looking at, and you'll get the same inference of the treatment effect, i.e. the F-stat and the p-value will be the same. The advantage of doing subsampling is it's going to give you that extra information of the two estimates of variability, okay? Now, the other scenario is that we're in an unbalanced subsampling. This is when we have different number of subsamples per experimental unit. And this is when it does matter. And you have to do a subsampling analysis for your analysis to be correct. You don't want to give equal weights in the analysis to experimental units that have less information. What I mean by that is, or what I mean by information is that we're talking about the number of data per car. So for instance, if we have one car that was driven 2 times and another car that was driven 3 times, we wouldn't want to weight those the exact same by just, okay, and by averaging, we would be giving each subsample equal weight. Okay. So let's look at what I mean through the car mileage example. So here, I didn't put the data. You guys should have the data on the other lessons. I have the jump analysis for the mean. So when we average, just to make it clear, this is for when we average, and then when we have subsamples. Okay, so again, you can notice in this design, this was a balanced design, and so our F ratios are the same, okay? And so our inference about the treatment effect, so whether the treatment was impactful or effective or not, will be the same. What subsampling is going to give us is this extra component of being able to understand where the variability is within our experiment. What I want to do now is I want to talk about, and I'm going to actually go to jump to discuss this briefly, about what happens when we don't have a balanced design and how our results can differ. About what the results would look like if we had an unbalanced design and we did the analysis of the means and the analysis with the subsampling. So let's say we got rid of this guy and we got rid of maybe this gal. Okay, so we now have an unbalanced design. If we did our subsamples, we did analyze, fit, model. Again, I will do this a lot slower in our next video. For my jump users. And we run it. We're going to get a F ratio of 3.2. Okay? Okay. Now, let's look at if we did table, summary, mean of mileage by group. Okay, yeah. It's saying we have 3 rows here because we technically do have 3, but it's not averaging in that point because we can do the quick math to see that the average is there. Okay, so now we averaged our results and we're just going to run a simple CRD. So, boom, add brands, run. And if we scroll down here, let me bring up here. We can see this one here, our far right one, was with subsamples, and this one here, our far left one, was with averaging. We can tell that these two results aren't the same. And this is the effect of doing a CRD. This side right here is a CRD analysis that is unbalanced versus doing a subsampling. And the subsampling for an unbalanced design is correct. So the point of this was to show you quickly that these two F ratios here, 33.2 and 24, are not the same. In the next lectures, I will show you guys how to do this in R or jump a lot slower, and I'll show you in the balanced and unbalanced case again.